Now the last three questions on the Algebra Refresher packet, starting with number 32. So anytime you have to solve a quadratic equation, the first step is to make sure that that quadratic equation equals 0. If you don't equal 0 already, then make sure you subtract or add to make this equal to 0. Once you have it in that form, you may be able to factor and set your factors equal to 0 to solve, but you can always use the quadratic formula. And the quadratic formula is on the reference sheet on the ISTEP. So here's the quadratic formula. We need to identify A, B, and C in order to use it. So in this one, A is the number in front of x squared, 1. B is the number in front of x, -6. C is the number, the constant, 14. So I'm going to plug these numbers into the quadratic formula. So x is going to equal the opposite of the b value, -6, plus or minus the square root of b is -6 squared minus 4 times a is 1 and c is 14. This is all over, all divided by 2 times the a value, which is 1. So now we got to simplify. So the opposite of -6, we can calculate that, +6. Keep the plus or minus, keep the square root. -6 squared, -6 times -6 is +36. If you use a calculator, make sure you put parentheses around your negative numbers. And then -4 times 1 times 14. There's one negative, so it's going to stay as a negative subtraction. 4 times 1 is 4. 4 times 14 is 56. And 2 times 1 is 2. And so now we're going to finish the subtraction. So after you square b and multiply 4ac together, then you can subtract them. 36 minus 56 is -20. So if I'm getting x equals 6 plus or minus the square root of -20 over 2, if we have a negative number inside the square root, that gives me an imaginary number, or a not real number. And ISTEP is not going to look for imaginary numbers, so what we would just say in this situation is that there is no solution, because you can't take the square root of a negative number and have a real number as an answer. So in 33, it says solve using quadratic formula. So first step, set the equation equal to 0. So we got to subtract the 4 over to the other side so that the equation equals 0. So my A is 2, B is -4, C is -4. So put it into quadratic formula. X equals the opposite of -4 plus or minus square root b squared minus 4 times a times c. All of that is being divided by 2 times a. So simplifying, opposite of -4 is +4 plus or minus square root. -4 squared is 16. Negative and another negative make for positive. 4 times 2 is 8. 8 times 4 is 32. And this is all being divided by 2 times 2 is 4. Now if you can type all that into the calculator and use all the parentheses, that works, but it might be helpful, might be easier to get it down a little bit further before you try that. So now I've got x equals 4 plus or minus square root of 16 plus 32 is 48 divided by 4. So now I need to simplify square root of 48. So there's a couple different ways. If you can figure out what perfect square, what number do you know the square root of that divides evenly into 48, that's a good way to separate square root of 48. If you can't come up with that, then we can also take this 48 and think, okay, I know it's 6 times 8, and 6 is 2 times 3, 8 is 2 times 4. There's nothing to multiply to get 2 or 3, but 4 is 2 times 2. So anytime that you have a number that has a pair, a partner, I've got 2 pairs of 2's, but then this 3 is by itself. So the 2's go outside the square root. So if it has a partner, it goes outside. So I take this 2, put it in front of the square root, take this 2 in front of the square root, but this 3 doesn't have a partner, so it stays inside the square root. So the ones that are outside the square root can get multiplied together. 2 times 2 is 4. And now we look at these 3 numbers that are outside the square root, 4, 4, 4. What can I divide all of them by? 4. And so if you do that, divide each of them by 4, you're going to get 1, 1, 1. Well, dividing by 1 doesn't do anything. So I'm going to have 1 plus or minus 1 times square root of 3, or just square root of 3, all divided by 1. So 1 plus square root of 3, 1 minus square root of 3. So if we wanted decimals, we could type each of those into the calculator to get decimal answers if that is desired. Those are the 2 solutions. 1 plus square root of 3, 1 minus square root of 3. Number 34. So, a football player is punting a football. And, let's see, hang time of more than 4.5 seconds is good. He can kick the ball with an upward velocity of 80 feet per second. His foot meets the ball 2 feet off the ground. This can be described by the function, there's my equation. So what's happening in this problem is Manuel is kicking the football. It starts 2 feet off the ground. He's going to kick it up in the air, and eventually it's going to land. And this is going to make a parabola shape. Anytime something goes flying through the air, is thrown, kicked, it follows a path that makes a parabola. So how long is the ball in the air when it reaches its maximum height? So its maximum height is the vertex. And so to find the vertex, we take this equation and we have to find negative b over 2a. So from that quadratic formula, negative b over 2a, that gives you the x-coordinate of the vertex. So I'm taking this as a is negative 16, b is 80. So negative b over 2a means the opposite of 80 over 2 times negative 16. And negative 80 divided by negative 32. Take my calculator, negative 80 divided by negative 32 equals 2.5. So the vertex is 2.5 units horizontally. So it took 2.5 seconds. And so usually in the problem it will tell you that t is time, number of seconds. and then the vertical axis is typically height. And I see feet per second, so this is in terms of feet. So how long is the ball in the air when it reaches its maximum height? It had traveled for 2.5 seconds, 2.5 along the x-axis, before it reached its maximum height. What is the maximum height? Well, to find that, I gotta find the y-coordinate to find out how high up. What's the y value at the vertex? So I'm going to take 2.5 and plug it in to the equation for t. So the height is -16 times 2.5 squared plus 80 times 2.5 plus 2. So I'm going to take my calculator and type that in. -16 times 2.5 squared plus 80 times 2.5 plus 2. We get out of the glare, we see 102 feet. So the maximum height, the height of the vertex, is 102 feet. What is Manuel's hang time? Well, hang time refers to how long until it lands on the ground. And so we're trying to figure out what is the amount of time, the x-coordinate, when it hits the ground, when it lands. So we're looking for the x-intercept. Well, the x-intercept is the solution for when this equation equals 0, when the height is 0. And so to solve that equation, we could try factoring, but typically quadratic formula is what's going to solve for t. So I'm going to take this equation, and using the quadratic formula, we're going to say the amount of time, x, or t, equals the opposite of the b value, so the opposite of 80, plus or minus the square root. B is 80, so 80 squared, minus 4 times a, which is -16, times c, which is 2, all over 2 times a, which is -16. And so now we just got to calculate that, and it says round to the nearest hundredth, so I'm going to want this in decimal form. Now notice there's going to be two answers here. We're going to get one that's a negative number, where the parabola would have crossed the x-axis, and then a positive number. We want the positive number. So I'm going to take -80 plus or minus square root, and so I'm going to take my calculator and I'm going to type in 80 squared, because it's positive I can go without parentheses, 4 times -16 times 2. 6,528. 6528. And then on the bottom, 2 times -16 is -32. And so I'm going to solve this. I'm guessing square root of 6,528 probably does not come out evenly. And so I'm just going to enter that all in so I don't cut off the decimal. And so I'm going to type in -80 plus square root of 6,528. And then I'm going to divide that by -32. So that answer comes out to a negative number. Negative 0.02. Well, I don't want the negative answer, so I gotta do it the other time. I did it once with addition, now I gotta do a subtraction. So negative 80 minus square root of 6,528, and then divide that by negative 32, and I get 5.02. Nearest hundredth is 2 decimal places, so 4 is less than 5, so it rounds down, so I keep it at 5.02. And so we don't want the negative one, we want how long till it lands, which is going to be just over 5 seconds later. 5.02.